Hi there, I'm going to take you through some tips on locating faults, the third step of the BEalert process. So a quick reminder, this is a 6-step process, so if you've not carried out steps 1 and 2, it's simply not going to work. You need to now have the evidence you collected in step 1. You must have analysed this to give you some common denominators or good areas to start looking at in your diagnosis. And if you haven't and you're jumping straight to step 3, it's simply not going to work. You're going the wrong way and you're about to waste a lot of time. So go back. If you have carried out these 2 steps with a little bit of forward planning, you're in a really good place to go on and locate the fault. So normal question, where do I start? You need to say to yourself, can I reproduce these conditions that I identified in step 1? If the engine only starts when it's freezing cold, you really need to be diagnosing that engine when it's freezing cold. And this isn't always that simple. So if you can't reproduce the conditions, you need to make sure that you've either got some more evidence in the lines of common denominators or change points. If you've got no common denominators, no change points, and you can't reproduce the conditions, it is incredibly unlikely that you're going to be able to diagnose an intermittent fault. So you need to go back to steps 1 and 2 and try and get more evidence. If you can reproduce them, or if you've got this evidence, we're ready to create a plan of attack. The most important thing is that we don't just start diagnosing via a scattergun approach of randomly testing the vehicle anywhere. Equally, it might seem a good idea, but we really don't want to start testing a system from one end all the way through to the other, which is sometimes called point-to-point testing. Both of these methods are probably going to get you the fault eventually, but they're very, very inefficient ways of diagnosing a vehicle, and they're going to waste a lot of time. So here's some tips on how to do it efficiently. So this is all about narrowing down the area that the fault could lie in as efficiently and as quickly as possible. Now there's a few good methods that will help you do this, and they'll depend on whether the fault is mechanical, like a rattle, or electrical, like a horn not working. The method I'm going to show you is going to work really well for both types of faults. It's called the half-split approach, and it's pretty much exactly as it sounds. You split the circuit or the vehicle into 2 halves. Any halves, it doesn't really matter. In my example, we've got an annoying clunk when driving and we don't know whereabouts it's coming from. So I've split the vehicle into 2 halves. The next thing you need to do is choose a piece of equipment that lends itself to the type of fault you've got. This could be anything like a refrigerant leak tester, a fibre optic loop brake tester, or chassis ears. It could be a multimeter, it really doesn't matter. So the best tool in my example is VAG 1842, the ultrasonic chassis ears that's available to everybody through the tool hire scheme. What you do is you get the 2 channels or sensors from this kit and you place one in each half of the vehicle. You then get someone to drive the vehicle and you listen very carefully with the tool to identify where the fault is. And in this example we hear the clicking or the clunking coming from the back of the vehicle. All you do now is simply repeat the process by splitting the rear of the vehicle into 2 halves. Now we can hear in channel 1 that the fault is clunking away on the right hand side of the vehicle. So repeating the process a 3rd time will tell us again in a smaller area where the fault is coming from. Now do you see, when I carry this out 3 times, I'm always going to narrow down the fault to 1/8 of the circuit or the vehicle. What I could do now is go on to place one sensor on the body and one on the suspension, and it will narrow it down even further still. It's very, very useful. Now let me show you how to do this on an electrical fault. So on the top there we can see that the customer's complaining of 2 horns not working. So I'm going to pull up the current flow diagram, or it could be a pneumatic circuit or a schematic. What I want to do now is split this circuit into two halves, but just looking at this we can see, hang on a minute, we've got two circuits here because we've got a relay. We've got a primary circuit and a secondary circuit. So I'm just going to pick one, it doesn't matter which, I'm going to pick the primary circuit. Now I'm going to split it into two halves. And basic electric testing tells us that really we should be testing at the consumer. So I'm going to test at the consumer, and it's going to either pass or fail. The fault is either going to be in the first half or the second half. Whichever half the fault is in, we then split in half again. So in this example, the fault is in the other half. So I test that again, and then again, and just as before with the clunk, in three simple tests, I've split this circuit down to 1/8 of the circuit. But what if the fault wasn't in the first half and wasn't in the second? Well, this would tell us that the fault would have been in the secondary part of the circuit. So again, I just carry out the same process. I split the secondary part of the circuit in half, test it, find the faulted half, test it again, and very, very quickly I isolate it down to a very small area of the electric circuit. Now, you may have noticed that I didn't mention any evidence or any analysis that had gone on here. I want to show you this process again, but this time when somebody had actually brought together the evidence with a customer and carried out things like function tests. In this scenario, they noticed when they listened carefully that both horns were not making any noise whatsoever. So the circuit was completely inoperative. But also when listening, they also heard that the horn relay was clicking. Well, when you look at the circuit and you analyse this, you can see that that means the primary side of the circuit is working. So already we've isolated the supply wires, the coil, some more wires, the switch, some more wires, the earth point. And if this was the same earth point used for the horns, that would have been even better, but unfortunately in this case it's not. However, we've got two horns not working, and it's incredibly unlikely that we've got either two faulty horns or two faulty earths, because they are both different wires and different earth points. So if we look at common denominators, again that narrows it down even further to one wire and one switch and one connector point. So this has done an incredibly good job of isolating the fault right down to one piece of wire and one switch before I've even decided to go anywhere near the vehicle with a test probe. So bringing together the evidence, the analysis of common denominators, and the half-split approach is going to isolate this problem in an incredibly efficient manner. So, it is very, very important that before you start going up to the vehicle, you focus your evidence and make a plan of where you're going to test first, and then second if the first test was both a pass or a fail. If you do this, you're not going to get distracted, because it is so easy once you go to the car and do the first test to then get sidetracked and start testing things randomly again. Or worse still, you'll test something that you've already eliminated in your analysis. So, if you decide, like here, that you think that the fault is a connector, here's some tips on how to test the connector. When you look at a connector, if you decide to give it a bit of a wiggle or a touch or a pull and see how tight it is, all you're doing there is testing the connector plastic body. You're not testing the electrical pins. So we're going to do something called drag testing. And to do that, you need to start by unlatching the connector. Secondly, you need to very carefully undo or remove any locking clip or tool from that connector body. The third step is, using the special equipment, you can carefully unlatch the electrical wiring pin from the connector body and pull it out from the plastic housing. The next step is to then reconnect the wire without the connector body, and then drag it backwards and forwards on the pin to see if there is any resistance when you're pulling. This should feel very, very similar to when testing with a feeler gauge. There should be a significant amount of resistance there. If the pins are loose, then they must be replaced using the processes as detailed in ELSA and the wire repairing kit. So, in summary, this is a 6-step process. If you've not done steps 1 and 2, you must go back. Don't try and randomly test the car anywhere, and please don't test from one end of the circuit to the other. It just wastes time. You must make a plan of attack. Use things like the half split approach, be it on a mechanical fault or an electrical fault. And if it is an electrical fault, write down on the circuit first what it is you're going to test before you go to the car, and this will stop you from getting distracted or testing things that you've already eliminated. Finally, remember you can use the Be Alert pad, because this is really going to help to focus your mind and keep you on the track of steps 1, 2 and 3. If you do this, you're going to be one step closer to fixing the fault right first time. Thanks for viewing this short video. For more information on how to complete the other 3 steps, check out the other videos.